problem today, which is looking at a full Wheatstone bridge, full Wheatstone cantilever beam bending kind of scenario. So when we're doing problems in this class, we need to kind of read the problem statement and immediately start kind of writing down kind of variables. So let's read this together. Consider an aluminum 61 cantilever beam. So now I already know that my modulus is 69 times 10 to the 9. Oops, that 10 to the 9 pascals. I know my nu is equal to 0.3. Okay, continue reading. Full Wheatstone bridge configuration as seen below. So the gauge factor is 2, so F is equal to 2. The excitation voltage is 5, so VI is equal to 5 volts. Beam thickness, so our H is equal to 0.1 meters. The length, so our L is going to be equal to 10 meters. The initial resistances in each arm of the bridge are, so R1 equals R2 equals R3 equals R4 equals 120 ohms here. Why is this important? Because it means that we're balanced. So our initial V naught is equal to 0. So what is the change in voltage after this load is applied? So the load here is 1 times 10 to the 6 newtons. And we're in a beam bending scenario. So we're going to use this equation for our bending strain, where we have P, B, H, our height, actually our height is given here. Base of our beam is also 1 meter. And we see that the distance D here from where the load is applied to where the strain gauge is 8 meters. So go ahead and try to solve this problem. So first, looking at this kind of beam bending scenario, what is going to be the strain in 1, 4, 2, 3, and 2 and 3? Well, we're pure bending, so it's just going to be 1 and 4 are going to be positive bending plus thermal strain. 2 and 3 are going to be negative bending plus thermal strain. So we're going to find that our final equation, V naught over VI equals F times E bend. So now we could go to Mathematica. I know that my E bend is equal to 6 times, I want to do, let's define our variables. So P equals 1 times 10 to the 6 newtons. My Young's modulus Y is equal to 69 times 10 to the 9. My base is equal to 1. My height is equal to 0.1. And my D is equal to 8. And let's see, my F is equal to, let's move this over, F is equal to 2, and my VI is equal to 5. I think that's pretty much it. So let's plug in those values. So 6 times P times D divided by Y times B times H squared. And that is going to give me my E bend. And now I'm just going to plug in for my delta V naught is just going to be F times, so naught is equal to F times VI times E bend. And that's it. That's my strain, or that's my, excuse me, my change in my output voltage in volts. So again, make sure that those units kind of make sense and that everything works out unit-wise. So that's your first problem. So we're going to do some more examples now with configuration of strain gauges, and yeah, I'll see you in the next video. Thanks. Bye.